so have you ever wondered what's in the water that you're drinking, like what type of chemicals are in it? In this presentation, I'm going to be talking about how I found a chemical in a contaminated water sample. So in West Virginia, there was a chemical plant that leaked into the river, and this river is actually used for the drinking water. So this automatically brings up concerns because you don't know exactly if the chemical is harmful or not. And normally there's filters that stop it from going to the river, however there's so much of the chemical that it leaks through. So we use IR and MNR spectroscopy to determine what the compound could possibly be. So IR, or infrared, determines the functional groups present in the compound. Depending on the graph where the peaks fall in the absorption range, it indicates what functional group is present. So if you have the oxygen and the hydrogen bond, and it falls, like there's a peak at 35 to 30,000 range, and that means that that functional is present. So MNR, or nuclear magnetic resonance, determines the different types of hydrogens and their ratios. So as you can see from this chart, there's 3 peaks, and that indicates that there's 3 different types of hydrogens. And the opposite side, there's the number 2, which indicates that there's 2 hydrogens in that type, and then 3 in another type, and then 3 in another type. So that gives us a ratio of 3 to 2 to 3. Or 3 to 3 to 3. So for example of how you can determine it from the Lewis structure, I use ethanol. So in the black you can see that there's a carbon and hydrogen functional group, and then an oxygen and hydrogen functional group. And then in the red there's 3 circles, and that indicates that there's 3 different types of hydrogens. And this all has to do with the bonding. So there's a hydrogen bonded to a carbon, and that carbon's bonded to a hydrogen. And that's different from the second one because the carbon that the hydrogen is bonded to is actually bonded to another oxygen, so that makes it different. And then for the last one, it's obviously different because that hydrogen is only bonded to that oxygen. So you can determine the ratio by looking at the number of the hydrogens. So for the first one, there's 3 hydrogens, and then the second is 2, and the last one is 1. So this is the IR of the ethanol, and you can see that there's 2 different peaks right here and here. That indicates the oxygen and hydrogen bond, and then a carbon and hydrogen bond that's present in the compound. And then once again, you can see the Lewis structure, and you can see that I circled those 2 functional groups. This is the MNR, and you can see that there's 3 peaks, and I circled 3 different types of hydrogens. And then there's 1 of one type of hydrogen, and then 2 of another, and then 3 of the other. So that gives us a 1 to 2 to 3 ratio. So we composed a graph of all the possible compounds that could be in the water. And so the first one gives us the functional groups that are in each, and then the last one gives us the types of hydrogens and the ratios. So this is the IR of the sample that we had from the water. You can see that there is a peak right here from 35 to 31,000, and that indicates an oxygen-hydrogen bond. And then there's another peak, and then 3,010 to 28,000, which indicates a carbon and hydrogen bond. So that means that those 2 functional groups are present. And then this is the MNR of the unknown compound, and you can see that there's 2 peaks. So there's 2 different types of hydrogens, and then there's a 1 to 3 ratio. So from looking at the charts that we made earlier, we can determine that the chemical has to be one of these 4, since it has either oxygen and hydrogen and the carbon and hydrogen bonds. And then we can determine that it's methanol because there's 2 types of hydrogens and then a 1 to 3 ratio. And you can see off to the side, I circled the 2 functional groups and then the 2 different types. And you can see that there's 3 hydrogens and 1 of the other. So for some background information, methanol is often used as a solvent, pesticide, and fuel source. According to CDC.gov, it can occur naturally in foods like fruit and vegetables, but poisoning normally occurs from drinking contaminated water. It can cause the eyes to be irritated and the skin to have a rash, and if inhaled, it can cause dizziness or nausea. However, if consumed, it can cause shortness of breath, convulsions, or unconsciousness. According to CDC.gov again, since the compound does not bind the soil, it can end up in the groundwater, which means that it can end up in the environment. And if it's exposed, it can cause the death of animals and decrease plant growth, and it can also affect animals' fertility and their behavior as well. So according to National Geographic, one way to clean it up is it can be flushed out of the distribution system. So that means that the water that the people get are clean. So to sum this presentation up, we use IR and MNR to determine the unknown compound in the water, and those two things give us the functional groups, the types of hydrogens, and a